All right, back with Bangalang for another coding session. Welcome. Recently we've gotten quite a few features done. I feel like we've made a lot of really good progress. You know, we have range-based for loops, anonymous procedures, swizzlings, structs of arrays. I feel like we really plowed through some features, but I feel like we're getting to a bit of a wall now where when I investigate some of the extra features to do, it's starting to feel like there's a bit of restructuring that needs to happen. So specifically with like enums and type members, and I think with some other features that will help also, it's getting a little bit tricky because we need to differentiate between, like in this case, you know, we have a type as part of an expression, and we need to differentiate that from a type which is just like annotating a identifier or something. Like in this case, this type is just the type of this identifier, whereas this type is like in this flow of the, like it's in the main body, I guess you could say, of the AST, whereas this is more of an annotation. So I kind of want to reflect that better in the AST so that it's to disambiguate between the two. And that's going to help us with some of these new features. So if we go to the types for AST, here's our node. So I want to have like a data type here specifically, and that will hold the type information. But that needs to be a node. So then, you know, the children will be like the main, like it was kind of like the main body of the AST, but then if we need to annotate something with a type, it goes here. The problem and the reason there's an error here is because you can't do cyclic definitions like this. I made a note in my to-do list that I need to be able to check for this in our language, make sure this doesn't happen also. Because with all of our data types, we need to be able to calculate a size. But it's one of the issues with this. And because it's recursive in nature now, you're never going to get a size out of it. You're going to be calculating a size forever. You're going to get like infinite recursion or something like that when you're trying to calculate it. So really this needs to be a pointer. And when I investigate this further, it turns out that we kind of need to use pointers for nodes. Like for this to work, and I want these also to be nodes, it's going to be much easier if we just store our nodes as pointers all the time. I can't remember why, to be honest, but I just remember that's kind of the conclusion I got to. It was going to be really difficult if these weren't pointers also. So in the other place that I think, like in our type checking context, I think it is, we have these lists of nodes. I'm going to make them pointers also. And in our program structure, we also have lists of identifiers, static variables, just anywhere where we have references to nodes, I'm basically going to make those pointers. And now we're going to get a lot of errors. Okay, so to solve like these kind of errors, we need to make these pointers, right? And the way you would normally do that in Odin is you would say like, you'd create some node, and it would need to be new ast.node. And then to assign these values to it, I'd go like this. And then I'd put the node in there. But I don't want to do like 3 lines every time. That's kind of a pain in the ass. So I'm going to make a little utility procedure for this. Make node. Sorry, I'm getting my syntax confused. So we're going to call this an init, which is like the stuff here that we initialize it with. And because we kind of have confusion between type names and variable names, we'll just go new node and then turn new node. So that's wrapped it up into a little procedure. So now when we come back here, we should be able to just do like AST.make node with the stuff, like so. Cool. So we're just going to have to wrap all of these. So now all of our AST nodes are allocated on the heap. Because for all of our allocations, we are going through this make node procedure. Another benefit of that is that later on I could make like an arena or something and pass the arena in here so that all of our nodes get allocated from an arena, and that should be potentially a lot faster. So the other thing is that anywhere where we have anywhere where we are manually creating AST, we're going to end up with this problem also, because we're adding to children and we're just passing in a node where we need to pass in a pointer to a node. And I think we can, because this happens quite a lot, and this is a big refactor, let's see if we can flex some of our regex. Do some regex replaces, because I think that's going to make it a lot easier. So it's kind of like we're going to have stuff in curly braces after AST node, and then we're going to have a closing bracket. I'm just trying to wonder what we should do. So we could have in regex, we can say in brackets, so it makes a group. We're going to say within here we could have one or more not closing brackets. See, so that takes us all the way up to the closing bracket. And then just to refine it, we'll put a closing bracket also. And then we're going to replace that with this, with $1 in here. So this group that we made will become $1. So we should see here. Ooh, this is okay. So this immediate example here, we can see it's going to replace like too much stuff. So maybe we should actually have like closing curly bracket. Do we need to escape that? It seems like it's working differently whether we escape it or not. So let's escape it. I feel like these all look good. And then we don't need to put this bracket on the end. So we're going to replace AST node space all this stuff. So because we didn't include that in the group, we're going to need to put that there. Yeah, so this is going to get replaced with this, which looks right to me. I don't know. Let's try it and see what happens. How happy are we? Pretty happy, it seems like. This here needs a bracket. And this here has too many brackets now. I'm not sure what happened there, but the rest of it seems happy. Okay. So I guess we're going to have to go through a lot of this code and do a lot of, hopefully we can do a bunch of find and replace to do this. So these parsing, whenever we're parsing, this is when we're creating the AST in the first place. The first thing I'm noticing here is that we're returning a node. We should be returning a pointer to a node. So I'm going to say, let's not do regex here. I'm going to say that these are all in parsing, right? I think they're all parsing. Just want to double check that. Yeah, pretty sure they're all parsing. So they should all return pointers. Like so. Another thing we're going to find here is that like in the beginning, we're just like assigned to this node, but this node is just a pointer. So at the moment it's a null pointer, and this is going to fail. So actually we need to replace like this. I think we will use regex again here. We need to replace it with node equals AST.make node. Like that would be a good replacement. So if we go replace that one with this one, but because we're doing regex, we can say, because this is going to be different in different places, so let's make this a group and say it can be A to Z and underscore plus. I guess we need to escape maybe these brackets. Okay, that seems happier. And we want to replace it with this. And this here will be our $1. So we'll replace that with this. And that looks pretty good to me. So let's do a replace all. Hopefully that helped. Okay. And I guess we need to look through and see where we find some errors. There should be a whole lot of errors, but I'm not seeing them, which makes me a little bit nervous. Break for assignment. This one we already took care of. So let's keep going through here. Are there really no errors? Come on. Context hasn't been modified. 4 has not been modified. So here's this is another where it should be. Let's not use regex. This should be a pointer that it's returning. These are all paths. I really wish it would show me some errors. Okay, we'll do it this way. So this is type checking. Let's see if we can find some parsing errors. Generation, type checking. Okay, it's not showing any in. What did I do here? Maybe this was our find and replace going silly. I guess it needs to be like that. And here's another one that has an extra bracket. Yeah, we do have some places where that find and replace did not work. And then what's wrong with this? Oh, I guess it didn't manage to do this one. What's wrong here? Allocator node is a new call node, and then we append to the children this make node. Maybe that should not be there. There we go. Okay. So we're going to have to do just like, unfortunately, it's going to be just a bit of kind of cleanup stuff. All right. This kind of looks wrong to me because, Well, we're going to have a lot of this that we shouldn't have. I think I'm going to do like a regex replace again because we're going to find a lot of this. So let's make a group A to Z underscore plus escape this square bracket. So there's a lot of places where it's going to be like this. But because this is where we're like trying to get a pointer of a certain child, but because they're already pointers, we don't need to do this anymore. So I want to replace that with not an ampersand, and this is the group. Oh, we shouldn't have a bracket at the start either. Yeah, so this is just stripping off the ampersand basically in a bunch of places. Let's try that. Okay. What do we got here now? I'm still surprised, like, I guess there's like, it seems like there's a limited amount of errors that can come up, but I'm really surprised that there's nothing coming up for parsing. I feel like there should be parsing errors, you know? There's a lot of this, so maybe we can replace this, which was an error, with space equals like that. I think that was a copy replace error, so we try that. There we go, that's better. This one's missing a closing bracket for whatever reason. Okay, I think this should probably, there's only 4 of those. I think they should always be replaced with, yeah, basically like this. Does that one not have a closing bracket? Okay, I think there's going to be a lot of consequences to this. All right, we already don't have that many errors left. I'm kind of surprised. Maybe later. It seems like it's put the bracket in the wrong place, right? But maybe later we'll get more. So has it done it here as well? Yeah, sometimes the replace did that, it looks like. Let's see, we're getting down to not many errors left. Extra bracket there. Same thing here. Same thing there. Okay, interesting. So these are like making a node. I'm not sure if that's really necessary, but why not? And I don't know why that one didn't get replaced. Okay, so now suddenly we have a whole bunch more errors. I thought that was too good to be true. Okay, what do we got here? This is like generating statements. So this is pointers now, so probably that needs to be a slice of pointers. And these don't need to be converted to pointers because they already are. It's probably going to be a bunch of that kind of stuff going on. Let's close a lot of these files. It's one of the downsides to having lots of files now. I feel like it gets a bit messy with lots of stuff open. So what's the matter with this? Oh, maybe static var node. Shouldn't have the ampersand there probably. hopefully that fixed that. Yeah, I guess there's just going to be a lot of places where they should not have ampersands. Oh, there's some up here. I think that should not... See, so this is kind of a... We need to be a bit careful with these kind of things. Looks like it got a bit too overzealous with that. We need to be careful here because we've really changed the way that this works. And we might want to make sure that we still have the same behavior. So since we're just copying this node into here, but then we're like, because it's a pointer and then we override the contents of it, we're overriding what we put in here, which is not what we wanted. I actually kind of want something like a clone. So if we can put a clone of it in here, and then when we modify the original, it's not an issue. We're modifying that node, so I feel like this one actually should stay like that. But we need this clone node. So we have a make node. Now I want clone node. And clone node, I'll say that's the root. I don't know. So the clone is make node with the root. But then what we're going to do is say children is, we're going to empty the children of the clone. And then we're going to go through the children of the original node. And we're going to add clones of each of them to this new clone. So it's a deep copy. That's what I want. We never had that before. Whenever we did copies, it was always shallow and it never actually made copies of the children. So now we have a clone. So I think that's going to clean this up. Okay, yeah, that's happy. So I think that should be good for that one. We need to keep that kind of thing in mind when we do some of these copy replaces we've already done. Probably it's already an issue. There's going to be some places that we're going to have to fix, I think. That doesn't need an ampersand. This here, can I just do this? So that, again, that's like a shallow copy, which I don't really like. I think it's going to work. I just don't like it, so that's what I'm putting it to do. Member node, I guess that doesn't need to have an ampersand. What do we got down the bottom here? Another place where we don't need an ampersand. I noticed here when I was looking in here before that we have this condition here because I don't want to do this stuff on a scope. So I don't know why this is down here. I feel like it should be up there. Just say, you know, if we come across a scope node, just don't do anything. I don't think, it's another thing where, like, in practical terms, I don't think it will actually make a difference, but it feels more clear to me. Okay, what else we got here? We're going to probably have a lot of those that we need to fix up. Ooh. then there's another one, but this is, oh, this one didn't get caught. This should be make node, right? Like so, and then up here there's some more errors. I think this just doesn't need an ampersand. Yeah. Let me have another look down here. I just want to double check. What are we actually doing here? Swizzle member, we're applying a type to it, which is a brand new thing. Element type we are taking in. We're not making a copy of this, but I think that's okay because we're not going to modify that. Okay. All right. Onward. I guess that's because of the ampersand, is that what's wrong? Oh yeah, because these, yeah, so I guess anywhere where we find that, we just want to have that. And same with, what was it, this length type node? If we find ampersand that, we just want that. And then there's index. Okay. Looks like we have an error up here. Is that fine? Yeah, I think that's fine. Generate procedure takes in a pointer to a node. Is that not a pointer? Ah, another ampersand problem. Here we're creating a static var node, but yeah, for some reason it looks like our copy replace did not catch some places. So that should be good. We create a whole new node. Yeah, it's like a totally new node. Should be no issues there. This is where we're wrapping in a reference node. So we create this reference node. Then we say that the left-hand side type node is its child. Ooh, and then we say, then we replace the left-hand type node with this. So I think that's a bad thing. I think this will need to be a clone. Because otherwise, this is going to be a loop. Otherwise, you know. It's going to be a child of itself if we don't do clone. But I think now that we did do clone, it should be okay. I think there's going to be memory leaks like all over the show. But let's just pretend that's not the case. I think that one should be okay. Okay, what do we got here? These nodes that get returned from parse module need to be pointers. So there was parsing errors. I think our copy replace got a bit overzealous here. Oops. Leaf node, probably this ampersand. What else we got here? Let's start from the top. So this is saying to node for token. Okay. I guess to node should call make node and return a pointer. That would probably solve that. Wherever we were. Is it primary? Yeah, and now there's no error up there, so I assume that worked. Okay, I do think we need to be a bit careful here. This is another thing where we're like, we were making a copy of the node, then replacing what node is, and then appending the old node as a child. But because this is just a pointer, this is not a good idea anymore. So I think this is again where we want to like clone this node. Clone the node to make a new one, so then we can replace the original, since this is a clone, and then we add the clone as a child. Yeah, I think that's it. I think there's probably a few of these here. There's no error here, but this also does the same thing. I guess there's no error because this is getting assigned properly, but we do want this for the child node. Here's another child node one. Let me look for where child node is used. Okay, I think we caught all of those. All right. Here, I think we just don't want to dereference. And will this work? We're saying that they should be the same. I think that still makes sense. We'll find out. There will be errors when we go to run this. Looks like it's taken off a bunch of ampersands. We did play with this before, but I guess we didn't get it right. So maybe we don't want to make a node there, because we're just replacing like the value that this one's pointing to. So as long as we do that and give it the right children, which is a clone, yeah, I think that should be safe. I'm sure there's going to be a bunch of things like that where I didn't get it right. Hopefully it's not going to be too painful to fix them. I think we don't want to have that. Probably this ampersand. There we go. Let's close a bunch of these. This one needs to be make node. I really do want to do something better than this. I have some ideas about how we can do it, because I really don't like making all this AST manually. I'd like to avoid it. I think this is just getting rid of an ampersand. I think I'll replace, messed those up. They seem happy now. We don't want that. And these don't need ampersands. And up here there's an error. We don't want that. Is that okay that we just do that? I think so. I hope so. That one doesn't need pointer, or it doesn't need to be dereferenced. Interesting. What do we got here? So here we're creating a type node, which is a slice, and we're appending the type of the original node. Ooh, and then we are replacing the type of the original node. This feels a bit dangerous. This feels a bit dangerous. So this is the original type that we put in, I think, because we're in type checking. The job is to add type information. I think this is us adding type information. So if we're indexing this, this child node is like, yeah, the array of the slice. And so this is going to point to probably like a, could be a primitive, you know, like F32, U8, whatever. So here, because it's just a pointer to the type U8, this is going to clobber U8. So that's not good. And get type node. Well, maybe if we make this one a clone. So this is a clone of the U8 or whatever. And so this is adding the type. So when we go get type, we're getting that clone. And we're making it a child of slice. But then when we replace this is going to create an infinite loop. So I think, again, here's the clone. We want to say get a clone of it to put it in here. Get a clone of our type, put it in here, so then when we clobber this, we're not affecting the child that we just put in. I think that's going to be safe because we did a bunch of clones. Fingers crossed. So this again feels kind of similar. So is this okay? We're making a type node, adding that as a child and setting it. I think that's okay because we don't mess with it at all. I think that one's safe. You can get rid of those. Down here, I guess we just don't need these ampersands. This is what we just played with, right? And I think the deal here is that this does not need to be make, because we're dereferencing and then just replacing the contents of it. Yeah. Okay. Okay, I feel like we're getting there. This really feels like unnecessary, actually. I feel like we can just revert that. It's just a temporary thing. That doesn't need ampersands. That doesn't need an ampersand. I think this is just an ampersand thing also. Where are we? Here, for member name. Member type name. Member type node is reference type node. Oh. So maybe we need to do make node, because we're replacing it with a new pointer, and then it's already a pointer, so we don't need to do that. Don't need ampersands here or here. What do we got up here? Just a bunch of unnecessary ampersands, or missing ampersands, one of the two. Looks like our make node got missed in a couple of places, and that does not need to be dereferenced. And this is just creating a whole new thing. Element type node is put in, but it's not played with. So I think it's safe. Unnecessary ampersand. Okay. This is where we declare something, we put the node in here. I think that's fine to do like that. More unnecessary ampersands. I hope we're getting close here. We've been going for a while. So here we're just getting the type of identifier node and then putting it there. I think that's okay to do. I hope that's not going to cause trouble. All right. There's a couple more where we're missing the ampersands and dereferencing when we don't need to. What's index node? It got turned into a make node. Missing the ampersand here and there. Don't need to dereference. Don't need to dereference. Just a bunch of missing ampersands and dereferences that don't need to be there. And then we replace, I guess, like this. Another dereference. Okay. That file seems happy. So let's see what else we got. The scroll bar is still small. That worries me. That means there's a lot more to do. Missing ampersands. Didn't do make node. Don't need to dereference. Ooh, look at this though. That looks like trouble. That looks like recursion. And also we have this. So I think, so this is doing a call which we've identified as a conversion. And I think this is appending type information to the call. So this is like the return node. Which I guess actually what we're trying to say here is we want a clone of this. Like that. I think this is fine. And maybe this should also be a clone. Yeah, because otherwise if we put procedure node in here and then we make all this also a child of procedure node, that's going to create a loop. I think that's okay. I think I'm just going to make a best effort right now, and then hopefully we can figure it out when there's errors at runtime. Still got a small scroll bar, damn it. That should be a pointer, so I think these also don't need ampersands. Like so. Okay, so member node does not need an ampersand to start with. This should be make node. That should not be dereferenced. Now what's going on here? We're replacing type node with this new type node, but what is this type node? So this is like our SOA. So this is like a unique type node, I feel like. Because what I'm worried here is that we're going to override this type node. And that type node is going to get used in other places too, and it's going to cause havoc. But because this is like specifically an SOA, I think it's unique, so I think it's safe to override it. Interesting. So final LHS is not a pointer. I guess this needs to be a pointer that we pass in. And a pointer that we get out. That seems to have fixed it. missing ampersand, missing make node. So this is converting our SOA index. So this is where we like rearranged everything. So this original node, I don't think it matters that we like just totally clobber it. Just replacing the whole thing. Yeah, and it looks like we don't actually use any of these nodes. Like we take the values from them. We do use the child of the index, but I think that's fine. Yeah, I think this is all good. Child node, oh, here's another one where probably we want to do a clone here. Child node is like a clone of node. Then we update node, and then we take child node and make it a child. Yeah, that sounds reasonable. This case node is not a pointer, and we're trying to use it like a pointer, so probably we just want to do make node, just like that. Maybe we can say, can I do that? And then like that. Yeah, that's nice. Okay, let's run this again. Is it getting bigger? I don't know, maybe I'm just hopeful. That takes care of that. Is this again, I think this is like a temporary thing that we just create to put in here and generate, and then it's discarded, but whatever. Don't need to dereference those. Memory leaks everywhere. Oh, I think it is getting bigger. That takes care of that. Takes care of that. I guess that needs to be like that. Come on, we're doing it, we're doing it. Was it the only thing in that file? There's two of them in here. Simple assignment, what's the deal here? Just that shouldn't be ampersand. That shouldn't be ampersand. Oh, I feel like we're almost there. The scroll bar is getting bigger. Had so many errors. Probably this doesn't need to be an ampersand. One error. And it's just an ampersand thing. Okay, now we get to the runtime errors. After nearly an hour, we finally get to runtime errors. We still have some of these. I thought I fixed most of those, but I guess this one didn't get done, so that should be make node, like so. Here's another unique one. Although this is procedure type, I feel like struct type. Struct type, yeah, it's very similar. Try that. This is just a breakpoint for some reason. Okay. Okay, we're getting into legit errors. So, identify type node as null. I identifier node is type U8, that feels a bit wrong, doesn't it? Convert SOA index. Oh, that's right. We recurse down, and when we find an identifier, we get the type of it. And for some reason, we've gone down and we've found a type. So what are we actually looking at here? Byte equals U8. I feel like this is the very first line of code in globals. Yeah, on the very first line. So byte equals U8. Okay, so the right-hand side is just U8. So that makes sense that we have a type that we found, and we shouldn't be able to get the type of it. So honestly, I'm confused how this worked before. Okay, so the child is not a type. But what about if this is not a type? Because we're right at the top here. We're doing convert SOA. This node is a type. So get type is not going to work on a type, but it is going to be an identifier. So yeah, I feel like this is kind of a legit error. I feel like it should be like if the current node is a type, return -1. And we shouldn't need this, because if we recurse down into here, then we'll just get a -1 back. So child result would be -1. I feel like that was kind of a legit error, but I don't know, I'm a little bit skeptical that, we still get it. Are we still on that same line? Yes. Oh, wait a minute. Wait a minute. We shouldn't be type checking this as an assignment. This shouldn't get type checked as an assignment because it's a type alias. So it should get skipped. So I guess that's why it was not an issue before. So let's revert this. And the real issue is we shouldn't be going into here. Like if I run it again, it should be going, I think it's going into here. Yeah, but it should get caught by this. So because it should be an assignment statement. Yeah. So is that not true? Statement is an assignment statement. 3 children, the left-hand side is byte, and the right-hand side should be a type. So is it not getting caught by isType? Is this the first place where isType gets checked? No. This is parsing. Okay, that's too narrow. Let's go to here. So we're checking if it's a type alias. This is our statement, right? Assignment. Yeah, byte U8. So we step in. I guess we can step in to isType. Okay. So it's U8, it's still identifier though. So it hasn't been converted to a type, which should have happened up here in resolve types. So something here is not working. Oh, maybe that's why. Okay, it looks like we've got somewhere else. We're type checking a call. It's an import call. And the parameter is module. But when we try to get type, and we check if it is a type, we check if the last child is a type, we find that the last child does not exist. So the type information has not been added to this, and this is an import. So import is actually kind of special. It's defined here. This is module, and this is the type information. Wait a minute. String has actually not been defined yet, but we're trying to use it. How did that work before? I don't know. How could we have said, hey, use string when string didn't exist? That's crazy. How do we solve that? We kind of need to do this part after we define the string. The string is in the globals file. Or something that I did have in mind before was if we actually define import here, which is proc, I think it's module string libstring at none, but we don't specify the return yet, because the problem that prevented us from putting import in here was crap, we have so many files open. The problem was this return type, which is module, which we can't define that in here. So just put a note here. Return type is added later. So I'm thinking we define most of it. That's right, the second parameter has a default of empty string. And this here we add later. So I think it's in, is it in main? Yeah, this is the global stuff. We type check it all. Then we grab out the identifiers and add them to the program. So maybe as we're going through, we say if identifier equals import. Then we say identifier node is that node. Yeah, so then I think we just do the same thing. So this should add the return value, I think. We just need to import AST. So we're manually adding that return because it's kind of a tricky thing. So then we should be able to take this out, which is nice. Does that solve that problem? Okay. Okay, we're moving on. Playground, we have an issue in here where value it's saying is already declared. Okay. So that's probably type checking of arranged 4. And that's this one. And yeah, that's this one. Value is the element node, and it's saying the element node is already declared. Okay, so the first time we use it, we actually add a child to it with type none. So down here, it's going to have that type information already. And because this is an assignment, if the left-hand side has type information, that's how it says, oh, this must be a declaration. So it's assuming this is a declaration, this here. I mean, if we cut this out, does it still have the issue? No. Yeah, I think that's it. So I think we just need to clone this so that when we add the child, it doesn't cause that issue. Maybe we make all of them clones, because probably when we process, when that gets type checked, it's going to add a child to this, a type child, and then when it comes to here, it's going to be like, hey, there's already a type. Okay, that solved that one, and now we have something similar down here for this index. So it's probably a very similar thing going on. So this index node, yeah, here we give it the length type. So then down here, this assignment, it's already got a type, and it's going to be like, hey, what are you doing? So let's just clone this index node whenever we use it. I'll just clone it there as well. I don't know if that's as necessary, but whatever. Probably, yeah, why not? Let's see if that solves that. Okay, CoreOS Linux. Um, 22. It's probably here. It's like danger untyped is not working anymore. I did have an idea about a different way that I wanted to do danger untyped. I'm not sure why it's not working here, but let's... Yeah, so at the moment, we have it in type coercion, and we have it here, which is like upgrade types. I'm going to take it out of there, and instead, what's that? Oh yeah, the allocator has danger untyped, and this is some tests. So I've taken off those three, and instead, what I wanted to do is when we're type checking a primary, we do all the type checking, and when we get to the end, we say, hey, look, if this is supposed to be untyped, then we're going to override the type with a type of none, which then during type coercion will get upgraded to whatever the other type in the situation is. So like here, if we override the type of this with a none, then it's going to take the type that the syscall is expecting, which is I64. So effectively, it's going to untype this. We don't want to mess with the type that's already in there. So let's make a new node. Is there already a node that's like type node up here? No. Okay. So type node is make node. Type and value is none. And then we will say the last child of node, which should be the type that just got added. Let's set it, I guess we can just do it in one line, right? Just set it to be this new node. Replace it with the new node. +1? No, -1. So that should replace whatever the type that we decided it was with none. What happens now? Oh, I should have done debug. Well, we're going somewhere else now. I guess this is progress. So what are we doing now? We're doing a call. The procedure node is syscall. So we're calling syscall, generating expression for what are the parameters? And it looks like there's no type node. Yeah, there's no type node. So why would that be? Scope return call. So the only place we call syscall is in this file. It's one of these calls. It's one of these calls where we're passing in, a number literal, which is probably the first parameter. And it hasn't been given type information. So the question is, why not? Oh yeah, we can see it's a call to syscall with 1. So it's this guy here. Oh, this just quickly. I remember we added a bunch of these last time and there was one I missed. I went back and had a look. Where was it? It was in memory. To return. No, where was it? There's somewhere where I missed a do return. I'm sure it was the heap allocator. Maybe we fixed that up. Maybe we already fixed that up. Sidetracked a bit there. So why is this 1 not have a type? This expression node. Does not have a type. Well, let's go to type checking of a call, I guess. That's where it should get typed. Should get typed in here. It's the first parameter, so I don't think, because I was thinking maybe if it didn't quite get to the end with this list, with this condition somehow, but it's like the first parameter. So it should come in here and type check, and it should take the type from there. Type check right hand side expression. We put this in here. Is this going to not like... Sometimes it just crashes at the start of the program. So this is an assignment. That's the import. Call import. Calling print line. Right. It's probably the case for all of these, but let's go to the one that we know is the issue. Okay, here's a call. This is call 1. So let's step in. We'll step out of that. That's just getting the type. Step into here. So the node is the number literal 1. Cool. And it doesn't have a type yet. That makes sense. So now we type check, go in. It's not a binary operator, so we go into here. That should have no effect on it. Step into here. Don't have a child. We go into here. So the type should be any number. Where's type? Any number. So now we append any number on. It's not danger untyped, so the node now has the type any number. What would cause that to not happen? That's the only time that we type check that, which makes sense. It should only happen once. And we got number on there. And that was when we were type checking the call. So if we're type checking the call and we added number to the type information, then why is it that when we come here, the type information is gone? The expression node, which should be number literal. Oh, wait a minute. It's the default value. The default value doesn't have a type. Okay, why not? Yeah, we're looking at it and saying like, hey, there's no... So it's the default value for one of the parameters. We're going through... Yeah, I guess it's chosen the default from there. So that's actually when we type check the procedure that it should add that it should do this. Now potentially one of our clones could be messing us up here. We could be getting a bit overzealous with our clones. But the left-hand side, no, but this is, yeah, it could potentially be the clone business when we're type checking our call. Well, we only do the cloning when we're doing this for conversions, right? We didn't really change anything down here. We add the return type, so the procedure node we'll just get the type information from the procedure node. And the procedure node is an identifier. So it's just getting the type from here, and it's not cloning the type. So that's good, I think. In this case, it's not a module identifier, it's this one here, but it's the same deal. So I'm not really sure why it would not be type checking this right-hand side. Link import. Syscall. So this one, I think, so we get the param node, we have the param left-hand side node, syscall num. Okay, so now we're on param 0. This is where we actually have a default. So if we step in, I think we step over, it's not a procedure definition. We go in here. We type check the right-hand side. And then the right-hand side type node is I64. Okay. Whoa. Oh, that's okay. I don't think we need to do this. The left-hand side type node already has a value. Yeah, it already knows it's I64. So the right-hand side does have type information. But for some reason when we come in here, it doesn't. So somehow I feel like we've got a clone of this. So maybe we get more context. Where are we actually in the program? looks like type checking a procedure. So what procedure is it? Qualified name. So we're type checking the right procedure. We go into the scope. We go into return. And we generate the right-hand side expression of that return. Which I guess is the only child node of the return, which has that call. Yeah, that all makes sense. So yeah, we're doing a return and it has this call. And it looks like we've done all these parameters and then we get to one that has a default and it's like, whoa, 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 whoa. Like the parameter index is probably quite high. Yeah, it's like 4. So it's the 5th parameter. 1, 2, 3, 4. Yeah, so the 5th parameter is one where it's the first one where we need to do a default. And for some reason, this procedure node that we have attached to our call does not have all the type information on it. But this procedure node, we don't mess with it in here. It already has type information when we come in here. We saw that type information get added. When we type check an identifier, we just get the identifier. We don't take a clone of it so that then maybe later type of information gets added. So this type of information does get added later when the procedure is actually type checked. So could the ordering be wrong? No, but this is generation. At generation time, everything should have its types. Unless this call is just not getting type checked somehow. If I go to type check program, this is where all the procedures get type checked. So if I go format dot print line qualified name, we do see syscall in there. So syscall is getting type checked. So just global strings OS Linux. So syscall does get type checked. So the only thing I can think of is that somewhere we're doing like this clone and it's causing us issues. We're saying that all procedures are clones? Ooh, that could be it right there. That could be it right there. We do want to replace this node. So maybe we want to put the original node in here. This is what we want. We don't want that to be a clone. Here, maybe we can make a new node. No, that's not going to work. This needs to not be a clone because otherwise it's going to cause trouble. But we can't modify that. And the context that we're in means that we can't like go up and say, you know, like replace this within the parent. So this is a tricky one. How do we do this? Because oh, wait a minute. We're saying the identifier is the left-hand side of the new node. Can't we say that it's the... I guess we do need to do that because that's what's actually getting used. But then when we come along, and this is just the left-hand side node, so that should be okay, actually. This is a bit of a, I'm kind of just hoping that something works here, but if we do make node, that's like a shallow copy of the node. So it's going to have all the same children. It's going to have all the original children. And this is also going to have the same left-hand side. And here, I don't know, let's just see if that makes a difference. Whoa. that was like a, I was really not confident about this. I was like, maybe it'll do something, I don't know. Okay, so we actually got a program working. We're an hour and a half in. This has been a real beast. Thanks for sticking around if you have. But now the scary thing is, what if we do a more complex program? It's probably going to crash. We need to not print these things out. Okay, so we get wrong number of parameters passed to I64, which makes me think, because this again, if we go to OpenGL, 31, yeah, it's another cast. So it's like this still has too much information on it, like it's been double processed or something. So if we go to OpenGL, no, if we go to type checking a call, it's like we're in here. And we're getting this happening. It is in our compound literal. Right, because this is like an allocator thing. So we do create a compound literal. I think it's an assignment here. Yeah, see, we create this compound literal here. So maybe something in here is getting double processed. I think it's this. We put length in here twice. So probably during type checking, like this one gets type checked. And then over here, it tries to type check something that's already been type checked, which is something that does not really work right now. So if we clone those, whoa. Okay. Let's just see if playground works still. And fingers crossed the tests work. Come on, come on. No more tea. Been at this too long. These tests are taking a while. I thought they only took about 10 seconds. Okay. So I guess I haven't broken anything, but I probably have. And now everything is pointers. And let's hope that that was not pointless. Hopefully in the next session, we can now use the fact that we have like pointers like this. We can go back to our struct here and we can add our data type like this, and yes, as a node. And that will enable some more stuff for us. And also we want to make these nodes. Probably this could be a list of nodes. There could be more than one. But yeah, I think that's, you know, an hour and a half. I think that's probably enough for today. And it was a slog, so I don't know if many of you made it through. But thanks if you did. Thanks for stopping by. Have a good one. Ciao for now.